Hello guys, today we'll be discussing about truss. Okay, as we all know, truss, if we have to define actually, a truss is actually a network. Truss is actually a network, okay, of longitudinal, longitudinal, okay, members, longitudinal members which are joined, okay, at ends. Okay, so what do you mean by truss? Truss is a network of longitudinal members join at ends. Okay, for example, first example you can see to this example, and next there are other examples that I have drawn. Also these ones. Okay, you can see these are all made of longitudinal members. These are the longitudinal members I am talking about, which are joined at ends. These red dots that you are seeing, okay, they are joined at ends. Okay, and they are after they are joined, all those members, they will form a network, and that network or the frame will be called as a truss. Are you getting my point? Okay, so this is a simple definition of the truss. Coming to the examples that you have seen in the I guess in the railway bridges, right? Railway bridges, or also in simple bridges, you can recollect your memory, and also in some towers, for example. Okay, so coming back to our thing, that is, what are the assumptions that are made, if I have to speak about, while designing or while explaining the concept of truss. Okay, first, each members only carries axial force, axial force only. Okay, all the members that we have seen, the blue one that I have shown are the members, right? These are the members which only carries axial force, and there will be no transverse force. Okay, and the second assumption is external forces, external forces, okay, are at joints. Okay, so the red dots that I have shown are the joints. At these points, there can be some external forces, say F1, and here say F2. Okay, for example. And the third and the last assumption is each joint is a pin joint. Okay, each joint is a pin joint. It means if this is a member, and this is a joint, and suppose again this is a member, this is a pin joint. Okay, this is a pin joint, means it can rotate. But if we what if we can do like that, what if we continue and make a frame? Can it move right now? And what if we continue like this way? So here rises the concept of, what if the truss frame, okay, the truss frame is too rigid, or is simply rigid, or is very rigid, or you can also call is less rigid. Are you getting my point? It can be a rigid structure by joining all the members one after another. Okay, and it can be less rigid, it can be very highly rigid. So the next concept that comes after this is the concept of perfect truss. Okay, if I have to write, it is perfect truss. Just a minute. Okay, this is called as perfect truss. Now, what do you mean by perfect truss? Okay, you can see this example, right? This example. This is the example number 1. if you can see, there are 1 member, 2 member, 3 member, 4 member and 5 member. Means there are m equal to 5, and if you can see, there are 4 joints, 4 red dots you can see, right? So j is equal to 4. There is a formula that explains whether your frame or the truss frame is a perfect truss or not. That has to satisfy this formula. 2j is equal to m plus 3. So if we see this one, your m is 5 and your j is 4. So if we find out for this one, the example number 1, 2j is how much? 2j is 2 into 4, that is 8, and your m plus 3, that is in the right side of the equation, is, since your m is 5, m plus 3 is equal to 8. So you can see this condition is prevailing, that is 2j equal to m plus 3. Therefore it can be, this example number 1 can be called as a perfect truss. And in the example number 2, this one, you can see there are 1, 2, 3, 4, 5, okay, and 6, that is m is equal to 6. Again there are 4 red dots, that is j is equal to 4. If we can see, it will be like that. It will be m plus 3 will be greater than 2j. Okay, in this case we will call it as a redundant system. Means it is way too rigid. This one means it is more than rigid. If it is perfectly rigid or perfect truss, this will satisfy 2j equal to m plus 3. And if it is not, then m plus 3 will be greater than 2j plus 3. So coming back to our third example, this one, you can see m is equal to how much? M is equal to 4. 1, 2, 3, 4. And how many joints? 4 red dots. Okay, so j is equal to 4. If we put in on this formula, you will see m plus 3, okay, is less than 2j. M plus 3 is less than 2j. So you can call this system as this truss as deficient truss. Okay, deficient truss. Okay, or less rigid. This one is deficient truss. So if we have to remember this one, if m plus 3 is equal to 2j, it is called perfect truss. If m plus 3 is greater than 2j, it is redundant. Okay, redundant, are you getting my point? If it is redundant, it means over rigid. Okay, and if it is m plus 3 is less than 2j, it is deficient system, which is what we can call it as under rigid or less rigid. So to make it a perfect truss, it has to satisfy this m plus 3 is equal to 2j, where m is the number of members, that is the longitudinal members, and 2j is the j is the numbers of joints that we have shown with the red dots. I hope you have got the simple concept of truss or the truss frames and the 3 conditions using the m plus 3 equal to 2j, and the assumptions and the few applications or the examples that I have shown along with the definition. Thank you so much.